Alright, we've started to learn the basics of antiderivatives and integrals. We're going to continue on with that today, except today we're going to have the opportunity to actually find the actual solution, meaning the exact solution of the function that we started with, because we're going to be given a little bit more information. So first thing I want to talk about is if I give you the graph of the derivative. I want you to sketch the graph of two functions that have the same given derivative. Well, what I want to talk about is this is obviously a straight line, so I could actually write down what this derivative is, and we could say, well, it's the graph of the line y equals x. So the derivative of this is x. If I was to integrate that, I know I'd get x to the second over 2 plus c. The reason why we can sketch two different graphs of this is because we do not know any other piece of information other than the actual function itself would be x to the second over 2 using the rules of integration plus c. This c could be 3, it could be 4, it could be 5, it could be many, many different things. So, maybe it just goes through 0, 0. Maybe it's a parabola that goes through 0, 2. We really just don't know. We just know that it's parabola, and then it has a plus c value. So there's 2. I could make 100 more. The next example here, this one says, find the equation of y given the derivative and the indicated point 3, 2 on the curve. So we have an actual value that is on the function. That is going to allow me to be able to find the actual end equation instead of having to write plus c. So what we're going to do is I'm going to kind of get you guys used to seeing this in this way. Going back to differentials, we would have moved the dx to the other side. We're going to multiply both sides by dx. Now what we can do is put integration signs in front of each one, and then what this says is that we have y, and we could put the plus c, but it's not necessary because we're going to put the plus c on this side. So if we added 2 c's or subtracted 2 c's of neither value that we know, we'd still end up with c. In this problem, I'm going to integrate 2x minus 2 dx, and I did need to distribute that out. There is some other tricks to that, but we're not going to get into those right now. So we're just going to keep doing it the same way we have. So we're going to rewrite the 2x, raise it by 1, and put it over that new exponent, minus 2x plus c. So our function ends up being x squared minus 2x plus c. Now we still need to use this information. That's what's going to allow me to be able to figure out c. So we know that this is x and this is y on the function itself. So if I plug 2 in for y and I plug 3 in for x, I will be able to solve for c. I'll have 2 equals 9 minus 6 plus c. 2 equals 3 plus c. I'll subtract 3 from both sides. I get a negative 1 is my c value. So my final solution ends up being y equals x squared minus 2x minus 1. Looking at this next example, we're going to solve this differential. We will integrate both sides. So g of x ends up being 6x cubed plus, or 6x cubed over 3 plus c. So g of x is really 2x cubed plus c. This is my x and this is my y. So in order to figure out what c is, I'll plug negative 1 in, and I'll plug 0 in for my x, and I'll solve for c. That gives me 0, so c is negative 1. So my end solution is g of x equals 2x cubed minus 1.